Hello everyone, welcome to this math tutorial. Here is another question on advanced trigonometry. In triangle ABC, we are asked to prove that this identity, which is on the left hand side, equals what we have on the right hand side. Okay, so now the first thing I'm going to do is I'm going to draw the triangle ABC. Okay, and then I'm going to I'll need to first write an expression in terms of cosC and cosB, okay, which I'm going to substitute for cosB and cosC, and from there we should be able to to do every other thing. Okay, all right. So like I said, here is how to solve here is how to prove the identity. Okay, so we are given a triangle ABC, triangle ABC. Okay, opposite B will be side AC, which we can represent with lowercase letter b. Opposite C will be side AB, which we can represent with lowercase letter c. Opposite A is side BC, which can be represented with lowercase letter a. Now, the first thing we need to do, like I said, is to write an expression for, derive an expression for cosC, okay, and cosB. All right. Now, but to do that, we need to understand that now the three angles, okay, we have them to be interior angle. So if you apply angle sum property, okay, apply angle sum property, okay, of a triangle, angle sum property of a triangle, which states that the sum of interior angles, the sum of interior angles in a triangle is equals to 180 degrees. So which means the sum of angle A, angle B, and angle C is equals to 180 degrees. So like I said, because we need to first write an expression in terms of cosC and cosB. So what I'll do first is I'm going to solve for angle B and angle C using the same angle sum property. So this will be angle B will be equals to 180 minus parentheses angle A plus angle C. Then angle C will be equals to 180 minus angle A plus angle B. Okay, so that, which means cos B, okay, cos B will be equals to cos square bracket 180 minus the sum of angle A and angle C, close square bracket, and this will be equals to negative cos, this will be equals to negative cos A plus B. Okay, this is equals minus cos angle A plus angle C. Okay, then similarly, do the same thing with angle C. For angle C, we are going to have cos square bracket 180 minus the sum of angle A and angle B, okay, close square bracket. So this will be equals to negative cos angle A plus angle B. So now, which means in this case, okay, now that we have an expression for cosC and cosB, so we're going to what? We're going to substitute this for cosB, and we also substitute this for cosC in what we have on the left hand side. So we know that the left hand side is given to be 1 plus cos A minus B multiplied by cosC, which is the left hand side, okay, and this is the right hand side. So 1 plus divided by 1 plus cos A minus C, then cos B. now that we have that for cosB is minus cos A plus B. So which means we cannot have 1 plus cos A minus B. Okay, so for cosC, this will be minus cos parentheses A plus B. Okay, divided by 1 plus cos A minus C. Then for cos B, we have that to be minus cos A plus C. So we have multiply by, okay, this is multiply by, so let me use a square bracket. We have cos A, okay, plus C. Then close the square bracket. All right, so minus times plus, that will be minus. We have the same thing here, minus times plus, that will be minus. So this will be 1 minus cos A, okay, 1 minus the product of cos A minus B and cos A plus B, okay, divided by 1 minus square bracket, because minus times plus, that will be minus cos A minus C multiplied by cos A plus C. Okay, now this is where we can now apply what we call sum to product identity for cosine. So we know that cos A plus B, okay, that will be equals to cos A cos B minus sine A sine B. Then cos A plus C, okay, this will be cos A cos C minus sine A sine C. Then also for cos A minus C, cos A minus C will be cos A cos C plus sine A sine C. So I'm going to what? Substitute. Okay, also we know that cos A minus B will be cos A cos B, okay, plus sine A sine B. So I'm going to substitute this for cos A minus B, and I will substitute this for cos A minus C, and then this will be substituted for cos A plus C, like that. So which means we are going to have this to be 1 minus, that is, this will become 1 minus open square bracket. So we have cos A minus B, okay, cos A minus B, that will be cos A cos B, okay, cos A cos B, then plus sine A sine B. We are multiplying it by, then we also have cos A plus cos B. Now this will be cos A cos B minus sine A sine B. Okay, let me close the square bracket, then divided by 1 minus open square bracket. So this will be cos A cos C, that is for cos A minus C, that will be cos A cos C plus sine A sine C. Then multiply by, then we have cos A plus C. So for cos A plus C, this will be cos A cos C, okay, minus sine A sine C. Nice. Okay, now we can see that if I represent this as x, that is cos A cos B. If I represent this as x and I represent sine A sine B as y, and I do the same thing here, okay, we have what looks like what? Difference of two squares. Then also if I represent this as A and I represent this as B, and this is A, then minus B, then also we have what? We have difference of two squares. Okay, so from from difference of two squares, we know that x squared minus y squared, that will be x minus y multiplied by x plus y. So we have x plus y in this case, and we have x minus y. So which means the numerator will now be 1 minus, okay, open square bracket. So this will be, so we have cos A cos B multiplied by cos A cos B. That will be cos squared A cos squared B. Sin A sin B multiplied by negative sin A sin B. That will be sin squared A sin squared B all over 1 minus open square bracket. So in this case, this will be a squared minus b squared, because if we represent this with letter A and we represent this with letter B, so we have it like that on the other side. So we have a minus b. Okay, so this will be a squared, and a squared will be cos squared a cos squared c. We have cos squared a cos squared c. Then b squared minus b squared, that will be sin A sin C multiplied by sin A sin C. This will be minus sin squared A sin squared B. Okay, now this is very important. The next thing I'm going to do is to express numerator and denominator in terms of sign. So that is when I'll need to recognize one of the Pythagorean identity. Okay, we know that now. One of the Pythagorean identity, okay, is that cos squared. If you have cos squared A plus sine squared A, this is equals to 1. So which means I can say that cos squared A equals to 1 minus sine squared A. So similarly, cos squared B will be equals to 1 minus sine squared B. So I'm going to do that there. Then also cos squared C will be equals to 1 minus sine squared C. Okay, so I'm going to write, this will be 1 minus open square bracket. So this will be 1 minus sine squared A, okay, multiplied by 1 minus sine squared B, then minus sine squared B sine squared A multiplied by sine squared B all over 1 minus open square bracket. So for this one, this is going to be 1 minus sine squared A. Then for cos squared C, that will be 1 minus sine squared C. Then we have sine squared. We then have minus sine squared A. Then sine squared B. Okay. Again, now let's expand this before we now remove the square bracket. So we have, this will be 1 minus open square bracket, 1 times 1, that will be 1. 1 multiplied by minus sine squared B, that will be minus sine squared B. Minus sine squared A times 1, that will be minus sine squared A. Okay, minus sine squared A multiplied by minus sine squared B, that will be plus sine squared A sine squared B, then minus, so you can see we have minus sine squared A sine squared B in this case. So let me write it again because of the space. So we have 1 open square bracket, 1 minus sine squared B, okay, then minus sine squared A, okay, plus sine squared A sine squared B minus sine squared A minus sine squared A then sine squared b, all over. So this will be 1 minus, open square bracket, this will be 1 minus sine squared c, okay, then minus sine squared a, then plus sine squared a sine squared c, minus, this is sine squared a sine squared c, minus sine squared a sine squared c, sine squared a sine squared c. All right, so sine squared a sine squared b minus sine squared a sine squared b, this will be 0. Then this will be 0 as well. So this will now reduce to 1 minus square bracket 1 minus sine squared a, okay, minus sine squared b minus sine squared b, all over 1 minus, open square bracket, 1 minus sine squared a minus sine squared c. All right, so this is where we can now remove the square bracket. So if I put 1, okay, if I put 1, okay, you know, if we have minus 1 preceding the square bracket and we use it to what? To multiply everything within the bracket, okay, we're going to have, this will be 1 minus 1 plus sine squared a plus sine squared b, divide by 1 minus 1 plus sine squared a plus sine squared c. All right, so 1 minus 1, this will be 0. So everything will now reduce to sine squared a plus sine squared b, divided by sine squared a plus sine squared c. Okay, so this is still the left hand side. Remember, we want to use the left hand side to derive what the expression on the right hand side. Okay, so now this is where we can now apply the sine rule. Okay, now applying the sine rule, so we know that a divided by sine a equals to b over sine b equals to c over sine c is equals to 2r. Okay, is equals to 2r. That is the radius of circumscribed circle. That is when we talk about the proof for sine rule. Okay, so from here, now we have sine squared a. Now let's say I want to write an expression for sine a. Okay, so I'm going to equate a over sine a equals to 2r. And this will be equals to, sine a will be equals to a over 2r. So similarly, now sine b will be equals to b over 2r, and sine c will be equals to c over 2r, like that. So, and from there, let me continue from here. We should be able to prove the identity on the right hand side. So now that we have our sine a to be a over 2r, sine b to be equals to b over 2r, and sine c to be c over 2r. And from, we have that expression there, which is sine squared a plus sine squared b divided by sine squared a plus sine squared c. Then it means that for sine a, okay, we know that to be a divided by 2r. So this will be a over 2r. But we have sine squared a. So a over 2r squared plus sine squared b. That will be b over 2r. Then raised to the power of 2 divided by, then also for sine squared a, we repeat the same thing here. So we have a over 2r raised to the power of 2. Then for this, it will be c over 2r raised to the power of 2. Now let's bring out the common factor, both in the numerator and denominator, and that will be 1 over 2r squared. Okay, so which means we're going to have, from there we have, let's factor out 1 over 2r squared. Okay, both from numerator and denominator. So that will be 1 over 2r raised to the power of 2. Then I'll open a square bracket. Then we'll be left with a squared plus, this will be b squared divided by 1 over 2r, okay, raised to the power of 2. Then this will be a squared plus c squared. So this will cancel this. So now we have a squared plus b squared divided by a squared plus c squared. So we can say therefore left hand side is equals to the what? Right hand side. And that is 1 plus cos, the product of cos, 1 plus the product of cos a minus b cos c, okay, over 1 plus cos, that is 1 plus the product of cos a minus c cos b is equals to a squared plus b squared divided by a squared plus c squared. And we've come to the end of this tutorial. The noblest pleasure is the joy of understanding. Bye-bye.